This video is going to be part one of a two-part series of videos describing position, velocity, and acceleration functions and their graphs, and then how that information can help us describe the motion of an object as it moves through space relative to time. So we'll start off with how position, velocity, and acceleration relate to each other. If a position function is given to us as an initial or starting function, then we can describe its derivative as velocity and the derivative of that as acceleration. So if I'm given a position function, that's telling me how an object is moving through space. If I describe the rate at which it's moving through that space, that would be a speed. But not only just a speed, velocity is going to also tell us a direction in which it's traveling at that speed. And then if I want to describe the rate at which it's changing its speed, then that would be describing the acceleration of an object. Position functions are usually described as s of t or x of t. S comes from the Latin for spatia, which represented position. And if I take the derivative of position, or the rate at which I'm changing positions, I get a velocity, and not just a speed, but a direction at which it's traveling. And velocity functions are described as v of t, or the derivatives of position functions. So because it's telling us a direction, that is given to us by the sign of our value. So if it's a negative value or a positive value, that's going to tell us what direction it's traveling in. So we can never have a negative speed. So a negative velocity is going to mean that we are traveling either left or backwards or downward relative to our initial position. If I want speed, I can just find the absolute value of velocity, and that gets rid of whatever sign it had, and it always makes it positive, because speed is always positive. We can't have a negative speed, but I can have a negative velocity representing a direction. If it's a positive velocity, that would mean that it's traveling to the right or forward or upward from its initial position. So the sign of velocity is describing the direction at which it's traveling, and the absolute value of velocity is describing the speed at which it's traveling. If I derive velocity and find the rate at which I'm changing speeds, that's its acceleration. And we could describe that as a of t, or the derivative of velocity, or the second derivative of position functions. And just like velocity, we can accelerate in a given direction. And if it's a negative acceleration value, that means we're accelerating either left or backwards or downward from our initial position. If it's a positive acceleration value, then we're accelerating towards the right or forward or upward from our initial position. Velocity and acceleration can work together, or they can work against each other. If I'm accelerating in an opposite direction that I am traveling, then that must mean that I am slowing down. If I'm moving to the right, but accelerating opposite of that, then I must be slowing down. Or if I'm moving to the left or backwards or downward, and I'm accelerating opposite of that, I'm slowing down. If they're working together, if I am speeding in a given direction and accelerating in the same direction, I must be speeding up. So if I am going or moving in a rightward or forward or upward direction, and I'm accelerating in the same direction, my object is speeding up. And likewise, if I was moving to the left, backwards, or downward, and I was accelerating in the same direction, I would also be speeding up. So we can speed up moving forward or backward. It doesn't matter. As long as our velocity and acceleration signs are the same, then we are speeding up. If they're opposite signs, then our object is slowing down. A couple more things to note. If we don't have any velocity or any speed, we must be at rest. So finding zeros of velocity is the same as describing times at which an object is at rest. In these videos, in this class, we are just dealing with horizontal or vertical motion. And so an object in that case is going to stop before it changes direction. So if we can find zeros of our velocity function, or times at which our object is at rest, then we can set up some intervals around those times to determine what direction our object was traveling in before and after it came to rest. So we're going to find zeros of our velocity function, and then we're going to set up intervals around those zeros and test some values using our velocity function. And based on the sign value we get when we evaluate, we can tell what direction it's traveling in. So be careful, because zeros of a velocity function only describe when an object is at rest. They don't necessarily tell you what direction it was traveling in before or after it came to rest. We have to test those values using our first derivative test or velocity test. So take a few moments to analyze these graphs based on the behaviors that we discussed in that last unit, describing graphs and their derivative graphs and how those behaviors all relate to each other. So take a look at the distance or position graph. Think about the behaviors of this graph, whether it's concave up or concave down, increasing or decreasing, maximums or minimums, all those behaviors that we talked about in that last unit, and then really analyze and confirm the behaviors that happen with its derivative graphs. So if velocity is the derivative of our position graph, then it must be describing the slope of our position graph, or the rate of change of our position graph. And then the derivative of that is our acceleration graph, which is the second derivative of our position graph. So again, just analyze and verify all those behaviors are happening, and then think about an object moving through space. As it's moving, its position or changing its position, how is the speed changing, and how is the acceleration changing relative to that? In the next video, we're going to be doing some examples where we're using these qualities of position, velocity, and acceleration functions to describe how an object is moving through space.